Hey everyone, this is going to be a video with exercises on how to read and interpret motion graphs. This is an exercise taken from the TIPPERS workbook, which stands for Tasks Inspired by Physics Education Research. And it shows a graph here showing the motion for two children, Ariel and Byron, who are moving in a straight line along a hallway. And the horizontal axis is representing time, but the vertical axis is not labeled. So what this exercise is going to do is it's going to ask a series of questions as if this vertical axis represented position, and then we'll ask many of the same questions if the vertical axis is meant to represent velocity. So we'll give you some good practice shifting back and forth between reading a graph as a position graph and reading a graph as a velocity graph. So if you want, you can pause the video after each question, take 30 to 60 seconds to try to work out the answer to yourself, no more time than that, and then unpause the video to continue. All right, so first question is that if the vertical axis is position, does either child ever change direction? All right, so if the vertical axis is position, then the vertical coordinate gives the current position of the child along the hallway. So you can imagine there's a big number line in the hallway, there's a 0 somewhere in the middle, and then negative numbers in one direction, positive numbers in the other direction. So if we want to know how the child is moving, if we look at Ariel's graph, for instance, the graph tells us that Ariel starts at a position of -3, so she is maybe 3 paces to the left of the 0 mark, and then as time goes on, she moves closer and closer to that 0. So she's moving in that direction, let's call it the positive direction, and then at about 5 seconds, she crosses 0 and then continues to more and more positive position values. So this graph is telling us that Ariel is simply moving in a straight line at a constant, steady rate. So she does not ever change direction. What about Byron? His graph is a little more complicated, but if you look at the vertical coordinate and just see how it changes over time, it starts out at about -2. As time goes on, the vertical component or coordinate just gradually increases, hits 0, and then keeps increasing 1, 2, 3, and so on. So Byron's position is only ever increasing, it never decreases, which means that he also never changes direction. So answer to part A is no. Next question, do the two children ever have the same position? So for the children to have the same position at the same time, that means the coordinates for that event would be the same for each child, so their graphs would cross if they ever have the same position at the same time. That happens twice here, once at about 2 seconds, and again at about 9 seconds. All right, next, do the two children ever have the same speed? So if this graph is showing position on the vertical axis, then we know that the slope of the line represents the velocity of the child. The speed is essentially the velocity with no regard for direction. So you can think of the speed at any moment in time as being the absolute value of the slope of the graph. So this one is a little trickier. Ariel's line is a straight line, so it has some positive slope which does not change. So that means Ariel has a positive velocity and it is constant the entire way. For Byron's line has a curve to it, so the slope is not a constant value. So to determine what the slope of Byron's line is, you have to imagine attaching a tangent line to his curve. So, if I take a straight line and move it so that it just touches the graph at one point, wherever those two lines touch, the slope of Byron's graph would be the same as the slope of this line at that point. So the slope of Byron's graph at maybe around 2 to 3 seconds is currently less than the slope of Ariel's line. Over here, Byron's graph becomes steeper than Ariel's graph, so he has a greater velocity at that point. So Byron starts with a velocity that is less than that of Ariel, and by the end of this time period, has a velocity which is greater than that of Ariel. So there's actually a theorem in math that says at some point in between, Byron's velocity must be the same as that of Ariel's. And we can try to estimate where that would be by just taking a line parallel to Ariel's and seeing where it just touches Byron's graph. And it's a little hard to say for sure, but it looks like around 6 seconds. All right, and then final question for the position graph. Do the two children ever have the same acceleration? This one is even trickier. We have to think a bit carefully about this one. We know that the slope of a position graph gives us velocity. Acceleration is the rate at which the velocity is changing. So in other words, we want to think about how quickly the slope of each line is changing to determine the acceleration of each child. So if we look at Ariel's, we just said that her line has a constant slope. It does not change. That means her velocity is not changing, which means that Ariel actually has no acceleration. However, that's not the case for Byron. The slope of Byron's line is increasing as time goes on, which means his velocity is increasing. If his velocity is increasing, it is changing. That means Byron has some non-zero acceleration. So we at least know that Ariel has 0 acceleration and Byron has non-zero acceleration, which means that their accelerations cannot be the same. So the answer to D is no. And we could say acceleration for Ariel is 0, but acceleration for Byron is non-zero. Okay, so now we need to shift and think about this graph as representing velocity on the vertical axis. So now the first question, does either child ever change direction? Our previous answer to that was no. But what if this is a graph of velocity? So if this is a graph of velocity, then the vertical component or coordinate on the graph tells us the velocity of the child, which also tells us the direction that the child is moving. A negative velocity down here means the child is moving towards the negative side of the fictional number line, and a positive velocity means they are moving towards the positive side. So each child begins with a negative velocity, so they're moving in one direction, and they end with a positive velocity. So that means at some point in between they must have changed direction, and that happens when their velocity switches from negative to positive, which means when the graph crosses 0. So for Ariel, that would be here at 5 seconds, and for Byron, that would be somewhere around 6.5 seconds. All right, next up, do the two children ever have the same speed? All right, so previously when we had a position graph, we were looking for times when the graphs had the same slope. Now we're looking at a graph of velocity. So we need to know simply when the children have the same velocity. So that would be points where the graphs cross. So here at about 2 seconds and 9 seconds, the two children have the same velocity. So those are a couple of answers. Now it turns out there's actually potentially another answer here. So the question asks if the two children ever have the same speed, not velocity. Speed is velocity without regard for direction, so it is possible that the two children might at some point have the same speed, but be moving in opposite directions, one positive and one negative. So if we go back and look at the graph, there is indeed sometime, somewhere in this area where Ariel is going to have a positive velocity, Byron will have a negative velocity with the same magnitude, the same absolute value. And in that case, the two children will be moving in opposite directions, but with the same speed. And it looks to me like that happens somewhere just shy of 6 seconds. So maybe between 5.5 and 6 seconds. All right, so we actually have 3 answers to this one. All right, so that third one is pretty tricky and pretty easy to miss. All right, and finally, if the vertical axis is velocity, do the two children ever have the same acceleration? So for this one, we know that acceleration is the slope of the velocity graph. So this question is actually analogous to question C. For part C, we were looking for times when the graphs had the same slope. Our answer to this question will actually be the same as our answer to part G. The interpretation is just different. If the graph is velocity, the time when the graphs have the same slope means they have the same acceleration. So answer to this one would be, again, around 6 seconds. All right, and that's it. Thank you for watching.